Welcome to Cengage series. So this is the first problem which we are going to solve today. A rigid insulated wire frame. It is in the form of a right angle triangle ABC. It is set in a vertical plane as shown in the figure. So this is the vertical plane which is shown in the figure. So two beads of equal masses M each and carrying charges Q1 and Q2 are connected by cord of length L and can slide without friction on the wires. So these are the two wires. Okay. And this is the length of the cord by which the two charges Q1 and Q2 are suspended. Considering the case when the beads are stationary, we need to determine the angle alpha, and we need to find the tension in the cord, and also we need to find the normal reaction on the beads if the cord is cut out. So if the cord is cut out, we need to find what is the normal reaction. What are the values of charges for which beads continue to remain stationary? So Q1 into Q2, we need to find those values. Okay, so let's start this. So for solving this problem, we need to redraw the diagram in such a way like we need to make sure like all the forces acting on it are zero, like the concurrent forces which are acting on it are zero. So let's take the diagram again. This is charge Q, this is charge P, and here the angle is alpha, and here it is 90 degrees, as here it is 30 degrees, here it is 60 degrees. Sum of angles in a triangle is equal to 180, so we can claim it is 90 degrees. So when it is 90, it will be 90 minus alpha. It will be 90 minus alpha. This is charge Q1, this is charge Q2. Okay. And we'll take the concurrent forces which will be acting on this. So as this is string of length L, so it will be exhibiting tension. So the tension, and as this is charge Q, it will be executing a force like electromagnetic force, electrostatic force, which is Fe. So as both tension and as both tension and electrostatic field are in opposite direction, we can take this one as like T minus Fe. T minus Fe. And here for charge 2 also the same scenario appears. Tension and electrostatic force are in opposite direction, so we can take here T minus Fe. T minus Fe. Okay. And we can take the normal to this bead as N2, normal to this bead as N1, and the gravitational force be mg, weight be mg, and here also let the weight be mg. Okay, so we'll be using we can solve this problem by using Lamis theorem. Okay, so we'll know what is meant by this Lamis theorem. Suppose if there are three forces F1, F2, F3, if there are three forces and the angle between them be alpha, beta and gamma, so then according to Lamis theorem we can write F1 force 1 by sine alpha is equal to F2 by sine beta is equal to F3 by sine gamma. Okay, so based on this theorem we can also solve the following problem. So first we will take the case for N1. So N1 by, if you take N1 here, the angle between the opposite two, like this is the angle which we need to find. Okay, as this is 90 degrees and here it will be 60 degrees, like sum of angles in a triangle is equal to 180, so 60 degrees, this will be 180. So 180 minus 60, 180 minus 60, my 180 minus 60 will be 120, 120 minus alpha, so we can take this total as sine 120 minus alpha. Afterwards we can take it as mg divided by, so we'll take this force now, so mg divided by the angle between N1 and this one, this will be 90 degrees, so 90 plus alpha, sine 90 plus alpha will be cos alpha, which will be equal to T minus Fe. It will be T minus Fe divided by we can take the angle between this the angle between other two forces, T minus Fe, so other two forces, this angle, so it is 90, 90 plus 60. 90 plus 60 would be 150. So sine 150, it will be like sine 150. So sine 150 can be written as sine 90 plus 60. So which can be further written as cos 60. So we can write this as cos 60. Okay. So similarly, we need to find for the other n2, like for the other charge also. So we'll take n2 divided by, so n2 divided by the angle between other two forces, this angle. So here it will be 30 degrees according to sum of angles in a triangle is equal to 180. It will be 30 degrees, and this angle, it will be equal to 180 minus 30 minus 90. 180 minus 120, which will be equal to 60. 60 minus of minus alpha, it will become plus alpha. So we can write sine 60 plus alpha, which is equal to m into g divided by, and now to find the mg, like this is the force which you need to find the angle between this and this would be 90 degrees, as this is normal. So 90 plus 90 minus alpha, 90 plus 90 minus alpha, which is equal to sine 180 minus alpha, which is sine alpha, which is equal to t minus fe divided by, so t minus fe divided by this angle we need to find. This is 30 degrees, this is 90. 90 plus 30 would be 120. So sine 120 can be written as sine 90 plus 30, so which can be written as cos 30. So we can write it as cos 30. Okay, we have got equation 1 and 2. So now we'll divide equation 1 by 2. So we'll be getting the terms mg by cos alpha divided by mg by sin alpha, which is equal to t minus fe divided by cos 60 by t minus fe divided by cos 30. So this both will get cancelled, and we'll be getting sin theta by cos theta, which is equal to tan theta, and also cos 30 value is root 3 by 2, and sin cos 60 is 1 by 2. So 2 will get cancelled. So tan theta is equal to root 3. So theta is equal to 60 degrees we can take from here. Okay, we have solved the first part of the question, which says the angle alpha. We need to find the tension in the cord. So to do that one, we'll be using this first equation. So we'll use this first equation and we'll find the value of the tension. Okay, we'll be taking these two parts here. So mg by cos alpha is equal to mg by cos alpha is equal to t minus fe by cos 60. Okay, this alpha. So mg by cos alpha value, alpha just now we have derived, we got it as 60. So cos 60 is equal to t minus fe by cos 60. 60 cos 60 we can cancel. So t is equal to fe plus mg. So what is the value of fe? Fe is nothing but electrostatic force, which is 1 by 4 pi epsilon naught. As the charges are q1 and q2, the distance between them is L. So this will be the formula for fe. So we can substitute it here. 1 by 4 pi epsilon naught q1 q2 by L square plus mg, we can take it here. So this is the value of tension which we have found, which is the second part of the question, the tension in the cord. Okay, and we also need the normal reaction on the beads. If the cord is cut now, what are the values of the charges for which beads continue to remain stationary? We'll try to find the equations for normal. To do that, we can take these two equations again. These two equations we can take. This equation and this equation we can solve, we can solve this one independently, this one independently. We'll get n1 and n2 values. We'll take this equation first, which is equation number 1. n1 by sin 120 minus alpha is equal to mg by cos alpha. So n1 by sin 120, alpha is 60, so it will become sin 60 is equal to mg by cos 60. So sin 60 is 1 by 2, cos 60 is root 3 by 2. 2 will get cancelled. This root 3 will go here, so we can write n1 is equal to root 3 into mg. Okay, so let this be equation number 3, and similarly we can equate the second half, which is n2 by sin 60 plus alpha, n2 by sin 60 plus alpha is equal to mg by sin alpha. is equal to mg by sine alpha. So if we equate this, we'll get n2 by sine 60 plus 160 120 is equal to mg by sine 60. We can write this sine 120, we can solve sine 120. This will be equal to sine 90 plus 30, which will be equal to cos 30, which will be equal to root 3 by 2. Okay, so this will be equal to root 3 by 2 is equal to mg. This is also root 3 by 2. So root 3 by 2, root 3 by 2 will get cancelled. n2 is equal to mg. So this is the value of n1 and n2. And also apart from this, we are also asked to find what is the like if the string is cut out, which means if t is equal to 0, what is the value of q1 and q2. We'll use the above equation itself. In this, if t is equal to 0, we'll check what will happen. So if t is equal to 0, we can write the equation as 1 by 4 pi epsilon naught q1 q2 by L square plus mg. Okay, now we can write this thing as we can send mg to LHS side. It will be minus mg is equal to 1 by 4 pi epsilon naught q1 q2 by L square. So finally from here we can write q1 into q2 is equal to minus 4 pi epsilon naught mg into L square. Okay, so this is the required solution for the given problem. I hope you understand this problem. Thank you.